So this next example is kind of a fun example. It shows how to use a modern Java BiFunction lambda to replace all the values of all the keys in a concurrent hash map. And we're going to compare and contrast this with the traditional way of using a conventional Java 7 solution based on a for each loop. So this particular program is one that plays upon some fond memories from my childhood on Saturday mornings watching this Three Stooges do their zany physical slapstick comedy act. And I don't know if you know much about the Three Stooges, but they were a bunch of brothers who actually weren't stooges at all, that they were just very clever at pretending they were stooges, and they made a lot of money pretending to be really dumb. So when we use the word stooge and we give them low IQ, we're not actually making fun of them. That was their vaudeville act, and they became quite popular and successful because of it. So here we're going to make ourselves a stooge map, which is going to give our estimated IQs for the various stooges. And I think everyone who's watched the Stooges would agree that Mo was probably the smartest of the three, probably followed by Larry, then followed by Curly, who was not particularly intelligent, but boy, was he funny. So here you can see we're making ourselves a stooge map that maps a string name to the person's purported IQ. And then we print out the stooge map. Then what we're going to do is we're going to use the traditional Java 7 for each loop approach, and we're going to go through every entry in the stooge map, and each entry will come back as a map entry object, mapping string to integer. And we're going to set the value of each entry to be the current value minus 50, because maybe we discover the stooges were even more stoogey than we thought. So they're going to have even lower IQs based on this whimsical model. And then we're going to print out the new stooge map. Then what we're going to do over here is we're going to come along, and instead of doing it with a Java 7 for each loop, we're going to use the replaceAll method and the Java BiFunction lambda. So what replaceAll does is replaceAll lets you provide a BiFunction lambda expression, which in this case is going to be key and value pairs. Now, if we want to, we can go ahead and expand this and turn it into that. That's a more verbose way of doing things. But if we want to keep it simple using type deduction, we can just say open paren k comma v close paren. And in this case, what we're saying is apply this particular BiFunction lambda expression to every element in that map. And so what we're doing is for each element v, we're subtracting 50 from v and updating the value of that key with the updated value v. Now, why would you choose one of these approaches over the other? Well, there's a lot of reasons. First of all, it's probably a lot clearer what's going on when you look at replaceAll, because you're replacing everything with this BiFunction lambda. So I think it's just more intuitive once you understand functional programming. This approach, not quite as intuitive. And there's a second reason why this approach is problematic. This approach here, the traditional way of doing things with a for loop, is not thread safe. So if you were to call that loop from multiple threads in a program on a concurrent hash map, chaos and insanity would ensue, and you'd have all kinds of wacky results. In contrast, this approach is much cleaner, and it synchronizes the updates to the map within the boundaries of replaceAll. So this code is more trivially thread safe and more compact and more intuitive and more functional, et cetera, et cetera. This is also a nice example of how modern Java allows you to be able to add functional features to traditional non-functional collections. So map, concurrent hash map, hash set, and so on, were not initially designed to be functional, but they were retrofit to be functional. And there's a whole pot of discussions we could have at length about whether allowing side effects and mutability is really functional or not. We're not going to have that debate right now. Java decided a long time ago to be a hybrid approach to this. But it's probably not a bad idea when you write your own code to try to preserve the stateless nature of functional programming, even though a lot of the infrastructure code for legacy reasons had to be mutable as well as being functional.